Hello everyone! This is our first online lab class. I hope everybody is safe and well. Keep following our recommendations about coronavirus outbreak, right? And today I will talk about soil color determination. Let's go! Okay, for this first class, this first online lab class about soil color determination, our goals are: the first, understand the factors influence the soil color, and the second one, understand how the soil color can be measured, and the third one, understand the importance of soil color measurement, and finally, know new technologies available to measure the soil color. Okay, I hope you enjoy. Let's start now. You can see here the 12 orders of soil taxonomy. These are the main soils occurring in United States. And for example, alpha soils, Andes soils, arid soils, antisoils, gallisols, histosols, inceptosols, mollisols, oxysols, spotosols, ultisols, and verisols. And as you can see, the soil color changes between soils. For example, when you compare oxysols, oxysol is not common in USA, but when you compare oxysols and to mollisols, for instance, the color is totally different. Okay, also the soil color changes down soil profile. Do you remember? You have A horizon, B horizon, and C horizon. You can see here, for example, in ultisols, a clear difference between A horizon and B horizon. The A horizon is brown and the B horizon is red. Okay? And the idea is the soil color will change between soils and down soil profile. Okay? This is the idea. And now the first question is, what are the factors or conditions influence the soil color? The first one, soil organic matter. The soil organic matter will contribute to black color or darkness of soil, all right, basically. And the second factor influence the soil color is the soil minerals, the clay minerals. Do you remember? We have 2,2,1 minerals, 1,1 minerals, and oxides occurring in the soil environment. And as you know, the soil minerals are influenced by both parent material and weathering degree. Okay? Another factor is related to water content or soil moisture. And the soil color is totally different under dry conditions or wet or moist condition. Another factor is the soil particle size, coarse fractions, clay fraction. Okay, I will show ahead some examples about that. And finally, there are some oxidation and reduction process occur in the soil, and this is another factor and influence the soil color. Okay, I think the soil color is influenced by mainly soil organic matter, soil minerals, clay minerals, soil moisture, soil particle size, and some process, for example, oxidation and reduction occurring in the soil. That's it. Okay, this is a very simple picture or example to help you understand the soil color variation. And as you know, the soil organic matter will contribute to black or darkness, basically. And for example, quartz and the most clay minerals, for example, gypsum, calcite, kaolinite, gibbsite, and will contribute to white. And for example, goethite will contribute to yellow color, and hematite will contribute to red color, for example. And since we have different amounts of soil organic matter, kaolinite, gibbsite, goethite, hematite in the soil, of course, we have different colors. This is a chart and where you can see the influence of different minerals or organic matter on soil color. For example, hematite is ready, and you can see here the gypsum effect. You can see the calcite effect on soil color, and also on this chart you can see the effect of particle size. And if you compare, for example, hematite fine and hematite coarse, the color is different, right? And do you remember our class about mineral properties? And I think you tested the streak of some minerals. I don't know if you remember, but the the pyrite streak is black, as you can see here, and the hematite streak, remember, is red. Okay, that's it. Okay, and now let me show the effect of moisture on soil color. And please look this picture. This is a soil profile, and you can see different regions, different sections. My question is, can you see, can you separate different horizons? The answer is no. You can see here different regions, but influenced by moisture. You can see clearly a wet region and a dry region. Okay, look, the soil horizon is the same. This is an oxysol, for instance, and below the first white dashed line we have B horizon, but we have part of this B horizon wet and part of this B horizon dry. Look, the color is totally different. For this reason, you must report it if you measure the color under wet conditions or dry conditions. Okay? Basically, when we measure the soil color in the field, I can do this using a wet sample or a dry sample. And we must report this. Okay? The soil moisture has a great influence on soil color. Now, let me show you the oxidation and reduction process effect on soil color. You can see here a beautiful picture. You can see different colors, for example, gray color and yellow color and red colors. It is this situation, it's very common, for example, in hydromorphic soils, in waterlogged soils, in wetland soils. Okay, what happened here? For example, if you look here in this gray region, what happened here? Under anaerobic conditions, there are some bacteria responsible to reduce the iron 3 to iron 2. The iron 3, as you know, is responsible for red color, and the iron 2 is colorless, and also the iron 2 is very soluble. the iron tool can be easily released. Okay? But you can see on this picture some yellow, some red regions. What happened here? Under aerobic conditions, again, the iron tool can be suffer oxidation process to iron 3 again. So this is a very, very common situation in some soils influenced by water fluctuation, water table fluctuation, for example. Okay, this process help to understand different colors occurring in the same horizon. Okay, you can see here gray, red, and yellow colors in the same horizon, in the same region in the soil profile. And finally, how can we measure the soil color? Taking a picture, observing, looking? How? Comparing? How? Let's go. Okay, let's start with a very simple exercise. What color is this? Tell me, what what's the color of square number 3? Okay, it's easy, it's blue. And now tell me, what's the color of square 1? Okay, it's blue, maybe dark blue. And now tell me, what's the color of square 5? Oh, it's blue too, but maybe light blue. Okay, and now tell me, what's the color of square 2? Oh my god, it's blue. Only blue, medium dark blue, I don't know, it's blue. And the square number 4, it's blue too. Maybe light blue, only blue, I don't know. Sometimes the color, the perception of color, it's not easy, all right? You can see below the blue squares, small squares with some very common soil colors. Look, can you tell me what color is? It's not easy, right? Sometimes it's difficult to separate some colors of different surface, of different object. Okay? Also, the perception of color is very, very, very particular. Okay? For this reason, there are some color systems to try to standard the color measurement. Okay? And now let me show you some color systems. Okay, let's go. Basically, we have four color systems. The first one, the Munson color chart or the Munson color system. And this is the most common in soil science. And also we have the RGB system, and also we have the CMYK system and the CLAB system, among others. All right, but basically we have this four color system: Munsell, RGB, CMYK, and CLAB. Okay, let me show you these color systems now. Okay, the Munsell color system was developed, proposed by Albert Munsell, and you can see here in this picture the color spectrum, and you can see different colors, and also you can see many Munsell codes, for example 5Y, 10YR, 10R, many codes. Okay, this code means hue, and the hue is a measure of the chromatic composition of light that reaches our eyes. Okay, basically the hue is the color: yellow, green, blue, red, purple. Okay, this is the Munsell color system. Okay, and in soil science, if you look this color picture in soil science, it's very common, the region between 5Y until clockwise until 10R. Okay, this is the Munsell color system. Okay, let's understand a little bit more about Munsell color system. Okay, and since you understand what means hue or the Munsell codes and 5Y, 10R, 2.5 IWAR, and now each hue or each color will be separate each other based on value and chroma. As you can see here on the right side, the value ranges from 1 to 9. What means value 1? Black. And what means value 9? White. From the bottom to the top. Okay? And you can see here on the right side, from the left to the right, The chroma. The chroma ranges from 1, for example, to 14. What means chroma? Chroma means the color intensity. Basically, chroma is the color intensity. And the value means the lightness or darkness of the color. Okay? To measure the color of any surface you want, based on Munsell color system, you can purchase, you can buy the Munsell soil color book. And as you can see here on the left side, and today the Munsell color book is around $200. It's not expensive, and each page of this book corresponds to the hill, the Munsell codes. Okay, and recently it was launched in the market, the portable Munsell color equipment. As you can see here, the right side, it costs around $800, and you can measure the color of any solid surface, for example soil, of course, and automatically. Okay, that's it. And here you can see an example of a page of Munsell color book, and you can see here on the left side, and from the bottom to the top, the value ranging from 2.5 to 8, and at the bottom the chroma range from 1 to 8. And how can I use the Munsell color book and bring to the field? And as you can see here on the right side, there is a piece of soil. Okay, we need a piece of soil. You can collect a soil sample, the soil profile, and you can measure the soil color under moist or dry condition. Compare the soil color using your eyes with the Munsell color chart. Okay, by comparison, you can try find the hill, the value, and chroma. And it's very important to measure the soil color under sunlight. Okay? And today, the Munsell soil chart is also available for smartphones, for Android smartphones, For example, you can download it and Play Store. And I think probably it's available for Apple too. And you can download it and easily find different colors. As you can see here on the left side, I have a color. The hue is 2.5 YR and the value is 4 and the chroma is 6. And the Munsell notation is, look, the right side, the Munsell notation is 2.5 YR for 6. Alright, and also you can see here the RGB. Okay, this is a correlation between the color, which color is according to the Munsell color system. This brown color is 2.5 YR for 6, the value is 4 and the chroma is 6, and the correlation with RGB system is the R is 138, the G is 81 and B 55. As you can see, the Munsell soil chart or the Munsell color system is semi-quantitative, and the RGB system, the CMYK system and the CLAB system is quantitative system. Okay, that's it. Recently, it was launched in the market the Nix Color Pro sensor, as you can see here on the left side. It's like a diamond, and you can measure easily and automatically the color of many kinds of solid surface. And it has a Bluetooth connection, and you can use your smartphone for connection, and you can record the color in different systems. For example, RGB, as you can see here, the CMYK and CLAB, among others. Okay, and it costs around $300, and it has been very useful in soil size. But unfortunately, it can't measure the soil color in Munsell system. And in soil science, traditionally, the soil color is measured based on Munsell color system. Okay. And There are some free softwares available on the net, and you can type on Google, and for example, this is a software. This is a free software, and as you can see here, you can enter the hue, the value, and chroma from muscle system and convert to different color system. For example, LAB, RGB, CMYK. You can export the color. It's very interesting to convert the color systems. All right, you can try. In this paper, you can see here the authors compared the NICS color sensor and the muscle soil color book, and the year is 2016. It's a very interesting paper about the soil color measurement and new technologies to do this. All right, I will recommend for you all the reading of this paper, and if you have any doubts or questions, you can send me a message, send me email anytime. I'm happy to help you. Okay? This is another paper using the NICS color sensor for soil color assessment. And since the soil color is influenced by organic matter, and it was possible to estimate the soil carbon, the soil organic carbon based on NICS color parameters, for example, LAB parameters. Okay. This is another paper from 2017 published in Geoderma, and again using the NICS color sensor, and now the authors proposed the app, the application for smartphones, and you can use the NICS color and a new app, and so you can take the picture, you can scan the soil surface, and you can easily convert the NICS color parameters to muscle color system. Okay, and also it's a very interesting paper. Okay. Okay, guys, that's enough for this week. You can find here some additional links about NICS Pro Color Sensor soil color determination, the field, the muscle system, and some materials for reading. And I hope you enjoy this online class, and have a great week. Take care, be careful, and stay home and wash your hands. I hope good times are come again soon. Okay? And if you have any questions, any doubts, please send me a message, send me email, and I'm happy to answer. I'm happy to help you anytime. Okay? See you next week. Okay? Bye bye, everyone.